Hey, what's up, everybody? It's Chris here from the Machine Learning Makerspace, and I'm going to be walking you through the example that we talked about in our workshop, which was about going through the looking glass, falling down the rabbit hole. So we're just going to start with this kind of diagram. This diagram is explaining the basic flow of our application. So you'll see that we have the entry point here, which is you ask a question. There's some kind of prompt chain utilities that happen. Then we get to augment the prompt with our LLM. We head to our tool chain where we can communicate with the LLM through our various search and tools, as well as use a memory buffer. So this is what gives our application the ability to remember from instance to instance so that it operates like a chatbot. And then we have our data indexing chain, which is how we actually put all this data into a configuration that will let us talk to it. So this is the idea that we're going to be able to chat with our documents. And at the end of all of that, we'll receive an answer to our question. So first things first, of course, we got to get started with just installing some dependencies. We're going to go ahead and install OpenAI and LangChain. So these are two awesome libraries. OpenAI's library is kind of what powers the programmatic access to the OpenAI endpoints that we're going to be using today. And LangChain is what lets us interact with the LLM in a kind of structured application way. First things first, we have to load our source data. So we're just going to be collecting various documents relating to Alice in Wonderland. So we'll get the first 4 books in the series of Lewis Carroll's Alice in Wonderland. So we'll get the first one as a text file, the second one is an HTML file, third one is another text file, and the fourth one is a second HTML file. So you see we have disparate kind of data sources, but that's no problem for LangChain, and we'll see how we handle that. First things first, we're just going to do some parsing. The reason we want to do this is just to tidy things up for later. So you'll see that we've just gone ahead and put our data into kind of an organized structure, and we're just using Python to do that. Now we can go ahead and get a dependency for our first loader, which is going to be our beautiful soup HTML loader. We're going to use the directory loader here. So we're actually going to be wrapping that BSHTML loader in the directory loader, which lets us use it for every matching file type in the directory. So we go ahead and do that here, and then we load it with the .load method. So basically what we're doing there is we're taking our data and we're loading it into this loader so we can parse through it properly when we're going to split it into manageable chunks, which we do here. You'll see that we're just splitting this kind of very naively into 1,000 wise chunks. We're using the len, so that's the Python character length, as our length function, and we're having an overlap of 20. And all you have to do is set that recursive text splitter up. Now what that's going to do is it's going to recursively split our text by a suite of characters. So if we look at the LangChain docs here, so first it's going to split by double new line, then by new line, and then by space. So it does this just to try to keep as many chunks of text together. So you know that paragraphs are important, so I want to keep those together. But we know that single new lines are usually more important, and of course spaces are the most important because we want to keep our sentences together as much as possible. So the recursive text splitter just takes care of that for us. Then we're going to have to use our OpenAI API key. So you'll just get this from OpenAI. And yeah, you'll be able to use it there. We're going to use the OpenAI embeddings model, which is the ADA model. And it's just a great, fast, and inexpensive way to do this. If you're using the API method, you could always substitute this for your own embeddings model. As long as you keep it consistent between what you embed your original documents with and what you embed your documents with when you're parsing through the queries. So like, let's say we ask a new query, right? We want to use the same embedding on that new query that we used to actually generate the original embeddings. Other than that though, as long as you're consistent, whatever embeddings model you use will be fine. And there's a lot of different approaches and ways that you can kind of tackle this problem, but for now, we're just going to keep things simple and keep it with the OpenAI embeddings. Next, we'll grab some more dependencies, of course. So we'll grab our ChromaDB and tick token. Tick token is what we need in order to be able to tokenize, and then ChromaDB is what we're going to use as our vector store or vector database. In order to set that up, we just import it with this line, and then we're going to use this persist directory. Now, what this does is it lets the application, it lets the database persist. So if we were to say, have this in our, application in real life or in a business, we'd be able to maintain that directory between sessions. And so it's important to use the persist directory in order to kind of keep it somewhere in memory so you don't lose it if the session restarts. Now, of course, in Colab, if the session restarts, it does dump the memory, so it works a little bit differently, but for right now, we're just going to keep things simple as the example, and we're going to use it to showcase how straightforward it is to persist your ChromaDB. We're going to pull the documents that we generated when we used our characters text splitter. We're going to use our embeddings model that we made, which is the ADA model, and we're going to pass that persist directory in order to create a chroma vector store from documents. We persist that and then set it to none. And then if we reinstantiate it, we find that all of our data is still in there. Now we do need to add some more information since there was only 2 HTML sources. We have 2 text files left, so we're going to add those now using the same method where we wrap the text loader in the directory loader and then load it up. We're going to split our documents in the same fashion, and we're going to use the same method we did to set up the initial ChromaDB to add new files, and you'll find that it does indeed add those new. So we have that Alice4, which is an HTML file, but then we also have the Alice1, which is a text file. So it just adds our additional documents, which is great. Now we're going to set up our tool chain. Our tool chain is kind of important. It's kind of where the magic happens, right? So you can think of the tool chain as a bunch of different individual purpose tools that our model can rely on in order to complete various tasks or requests. So first things first, we're going to set up a chat OpenAI model with temperature equal to 0, and we're just going to use the GPT 3.5 Turbo model. We could use the long context model, but just save yourself a few cents and use the normal version. Then we're going to set up our vector DB as a retriever. This is so that we can retrieve things as we pass queries to it. And then we're going to set up a retrieval QA chain. This is going to be from chain type. We're going to pass our LLM and our retriever. And the chain type we're going to use is stuff. There's a lot of different things you can do here, and there's a lot of different parameters you can tweak and everything like that. I just find this to be the most, straightforward way to get started. As you start working with these tools, you'll find what parameters work best for you. But I think this is the easiest way to think about it. This chain type literally just stuffs context into the prompt. So it's very transparent. You kind of know what's happening, and that means it's great to get started with. Now, when we run this chain, alice.qa or aliceqa.run, what is up with the Cheshire Cat? We can see that it gives us an answer relevant to the source material, which is great. Now, just in order to showcase the fact that you can do this, we're going to set up a second tool, which is going to be our SERP AI or SERP API tool, which is just going to search Google, basically. You'll need a SERP API key, which you can get for free, so you don't have to pay anything for it, and that'll let you Google, which is great, as long as you're staying within certain rate limits. If you're going to do a lot of searching, or you're thinking about using this in an application that's going to be customer facing, you'll probably wind up needing to pay for the API access. All right. Now we're going to set each of those chains up in its own tool object and put those into a list called tools. Now, we want to use, whatever name we want. The QA.run here. So this is aliceqa.run. This is important because this is what's going to be called on the text that we, associate with this tool whenever we decide to use it. And this description actually matters, right? So this basically is like what our agent is going to wind up seeing. So the thing that's going to decide which tool to use, it's going to look to this description in order to try to determine that. So you'll see we set it up useful for when you need to answer questions about Alice in Wonderland. Input should be fully formed question. And then for a backup Alice search, which is our SERP API tool, which we're again just using .run. Useful for when you need to answer questions about Alice in Wonderland, but only when Alice in Wonderland QA system couldn't answer the query, right? So it's going to actually matter. That line of text is going to impact how this works. Go ahead and just initialize a dummy agent. This is just so you can see it working with those tools. And don't worry too much about all this stuff. We'll talk a little bit about agents in a second, but for now we just want to see it, right? So we're entering the new chain. It gets the query, and the agent says, I'm not sure about the specifics of the Cheshire Cat, but it sounds like a character from Alice in Wonderland. So the action it decides to take is to use the Alice in Wonderland QA system, and the input it's going to give that tool is, what is the deal with the Cheshire Cat? It gets a response and makes an observation. The Cheshire Cat is a character in Alice's Adventures in Wonderland. And then it says it knows the final answer, and it outputs that final answer to us. So we can see here that the agent has a thought. It decides what action to take and how to take it, and then it makes an observation based on the output of that action. And so that's the basic idea of agents. We'll talk more about those in a second, but for now we're seeing it leveraging that tool. Now, of course, we'll want to add some memory. Now, there's two kinds of memory that we can use. One is a conversation buffer memory. This is kind of like a chat history. So what have people been saying in the back and forth in the dialogue? And the other is read-only memory. This is memory that you can give access to a tool, but the tool doesn't have the ability to modify or change it. So it's good when it needs to know context, but it doesn't need to make changes or do anything that would potentially mess up the memory. So we just recreate our QA tool, but we add this read-only memory. So again, it's the same kind of memory, but it only has the ability to read it. It can't edit it at all. We set up the same tool list here. This is identical to what we did before. And then we're going to set up this agent, right? So the agent is have a conversation with the human, answer the following questions as best you can. You have access to the following tools, and then the suffix, which is the end, begin. Then it shows the chat history, and it shows the question, which is our input. So that's the user question. And it has the scratch pad that it can use to think, write things down, make observations, and decisions. We create this zero-shot agent. Zero-shot agent here just meaning that, it sees something and makes a decision. We create the prompt using our tools, which is our tool list that we created above. Our prefix, which is, of course, this here. Our suffix, which is this here. And then we expose these three input variables so that we can have them be set by our application. Next up, we got to go ahead and create like the brain of our agent. So we're going to go ahead and use just a base ChatGPT 3.5 Turbo LLM as the brain. And the prompt is going to be that agent prompt that you see here. Now we can go ahead and create a zero-shot agent from this LLM chain, the tools that we originally gave it, and we're going to set it to verbose so that we can see it working. So that's the agent, but right now the agent doesn't actually have the ability to execute any of the tools. It just knows about them, and knowing about them is good. Knowing is half the battle, but it has to be able to execute them, and so that's why we create this agent executor, which is from agent and tools, and we pass it the agent, which we created here, which has knowledge of the tools, but can't use them. And then we give this agent executor the tools, as well as some memory. And that memory is going to help with the chat history that we talked about earlier. And again, verbose equal true, just so we can see it working. Now when we ask it a question, again, the same thing before, right? We ask it about the deal with the Cheshire Cat. It has this thought. It decides what action it should take. It decides how it takes it. It gets a response and makes an observation. And it has another thought. This time, it knows the final answer. And so it tells us what the final answer is. Now, you'll notice we can run this chain again with a new input. This query doesn't actually refer to the Cheshire Cat, but the agent's first thought does. And that's because of that memory, right? So it has a history of the chat. So it's able to leverage that in order to give us those details without needing to provide them again, which makes it feel more like a natural conversation. Again, it's going to go ahead and decide to use the Alice in Wonderland QA system and ask it this question. it gets a suitable response, and so it gives it back to us. We ask it, what are some of its riddles? This time, first things first, of course, it asks the QA system, but it can't actually get the answer, and so it falls back to that SERP API or that Google search, where it gets the observation and it is able to Google the answer, and it gives us that answer. Now we ask it, what is the response to that riddle? And again, we don't have to provide the riddle, right? It knows what we're talking about because it has memory. And it can find the response to that particular riddle in the actual Alice in Wonderland QA system. And that's really it. I mean, for as complex as these things can seem, what they're doing under the hood is, fairly straightforward. Basically, there's an LLM that receives input and it makes decisions on which of the tools that it has access to it should use for a specific problem. It sends an input to that tool. It receives an output from that tool, parses through it, it makes another decision. It does that until it makes the final decision, which is to tell us what it's learned or that the task is complete or whatever we've instructed it to do. So thanks so much for watching. I hope that you enjoyed this video. If you're brand new to the community, then welcome. We're excited to have you on board and can't wait to do more events for you guys. And yeah, have a great night, great day, and we will see you in the next event. Thanks so much for me and the whole Machine Learning Makerspace team. All right, peace out.